Okay, so before we get started hacking, we're going to go over each of the components we're using today very quickly. So this is the Arduino board. This is something that will make your life much easier when you're hacking hardware. And this is an Arduino Mega board. So what it has is a processor in the middle here, the ATmega 1280. That just means it has 128 kilobytes of memory. That you don't really need to worry about what that means. And so you'll see here that it's got a lot of components on it. You don't really need to know what they do. Basically, you plug in your USB cable that comes with it through here, and what it can do is it can receive commands from the computer, and you can program it that way and load a program onto here. So very soon we'll be writing actual programs for the Arduino, and they're written in a language called C, along with libraries that are written specifically for Arduino. Yep. So if you've ever written C before, this will be very natural for you. If not, well, this is a great way to get started. So the basic functionality of the Arduino is that it has a lot of switches, essentially, that control each one of these pins that you see on the right here. So you can plug cables into these pins and connect them to any part of your circuit. And the Arduino can supply basically 5 volts or ground. As Sid said earlier, voltage is not really a set quantity. It's relative. So you'll have a ground pin, as you can see where is it? Right here. You have a couple ground pins here. So and that'll basically tell you what your reference voltage is. That's what ground is. It's basically you say this is 0 volts, right? I'm going to say everything that's at this level is 0 volts, and everything is relative to here.
So the ground pin is labeled by G and D. So anytime you're trying to look for where your ground pin is, it should be labeled G and D on the board.
Yeah, and there's also a 5-volt pin and a 3.3 volt pin. So those will supply 5 volts more than ground and 3.3 volts more than ground. So the thing about these pins is that you can actually turn them on and off. And what that means is, so here we're moving from what's called analog electronics, where you can have basically varying voltages at different levels, to digital electronics, where it's basically the same thing, but in order to make things easier for us, we say there's only 2 things, on or off, 1 or 0. And we represent that by 2 different voltage levels. If it's at ground, we'll say it's 0 volts. If something is at 5 volts, then we'll say it's 1. So these are the signals basically that you're pushing out through these pins. So what you can do from the Arduino code is actually turn these pins on or off. You can say this pin will be at 5 volts or this pin will be at 0 volts. And you can do that basically as fast as the processor allows, and you do a lot of different things that way. So that's basically how the Arduino works, and we'll show you that there's actually a lot of things you can do with that. So moving on to the other components.
So here is a resistor. We mentioned this a little bit earlier in our water analogy. This represents like a tighter pipe. So all the resistor is that it has a certain value, and that is its resistance value. And this resistance value is measured in ohms, just a unit for measuring. And when you plug in these resistors, it'll help control how much current goes through your various other components, such as an LED. And so an LED is basically like a tiny little light bulb. You pass current through it, and it's gonna emit, light.
And Sid, what does LED stand for?
So LED stands for light emitting diode. And so a diode is a circuit component that only allows current to flow one way. This is really important because when you stick your LED into the circuit, you have to make sure it goes in the right way. So the LED is very interesting because it has that polarity. So I think we should probably draw on the board what an LED looks like from the top, so you can see. All right, so this is our LED circuit. This is how we would draw it in a circuit diagram, and later we'll show you how it actually works in the Arduino. But before, when we were talking about LEDs and how they work and their polarities, I just wanted to give a quick overview of how you can tell which side of an LED is positive and which side is negative. So if you look at the LED from the very top, then you'll see that it's a circle except one side is flattened out. So an easy way to know is that the flat edge, which is like a straight line, is the negative side, and the other side is the positive. Similarly, if your LEDs have different sized leads or legs, then the short leg is negative, the long leg is positive. Finally, the last way to know for sure which side is positive and which side is negative is if you look inside the LED's little bubble, you'll see a fat part and a skinny part. The fat part is negative and the skinny part is positive. Okay?
I'm going to show you right here. See this? This flat part is the negative side. And you can see the fat thing in the inside right there. It's also the shorter leg. The positive side, this edge here is curved, and the leg is long, and the thing on the inside is skinny. So those are the 3 things that you can use to figure out whether your LED, the polarity of your LED.
Okay. So now we get to our circuit. This is how we draw it in a circuit diagram. And all this is saying is that here we have a voltage source, and this could be something like 5 volts. Here's our LED, and you can see that it's like bright, and the current is flowing in this direction. And here's a resistor. The reason we have this resistor is that this LED only needs a tiny bit of current, right? So if you remember back to when we talked about Ohm's law, V equals IR. So the I that goes through this entire circuit, there's only one current through, that I is equal to 5 volts divided by 120. In other words, I equals V over R, which equals 5 over 120. So this is like a pretty small number, and we want that number to be small. If we didn't have that 120 ohm resistor, then I would actually be really huge. That R in that equation, instead of being 120, it'd be just some very small value, which is like the internal resistance of the battery. Like batteries have a tiny little resistor inside to make sure that things don't explode. But the issue is that in that case, if we did not have this 120 ohm resistor, the current would be very, very large, and that would completely burn out our LED. There'd be so much current that it would burn. But yeah, so essentially, with that current flowing through the circuit, the LED is going to turn on, and we're going to have a glowing LED. And that's what we're going to show you.
Right. So just some quick notes about convention. So I told you that electrons carry charge, and electrons are what move through a circuit. And you should know that electrons carry negative charges, negative and positive charge. But the thing is, a long time ago, Benjamin Franklin was like, I'm going to draw circuits. And he was like, I think positive charge is what moves through a circuit. Well, he's wrong, but too bad for us. Everyone has followed this convention from then on. So in a circuit, we say current as going from positive to negative, which is the reverse of how it happens in real life. But just remember this. So we're saying, whoops, the current is going from the positive terminal of the battery through the LED and through the resistor and back to the negative terminal. And this is the ground symbol here saying that this is our 0 volts, right? You start off with 5 volts here, you go through the LED, and it takes up some of that voltage, some of that pressure, and uses it as and transforms it into a different kind of energy, which is light, right? And then it goes to the resistor, which also uses some of the energy, the remaining energy, and that gets turned into heat. And then then you have no voltage left. You can think of it that way, and you're back down to 0, and then it starts over again. So yeah.
Okay, so this is basically a magnetic coil that we made using wire. So the way we made it is simply by literally coiling the wire around, and then to make it tight, we tied it off with a little bit of extra wire. So what this is going to do is that, as you might learn in physics class, when you pass a current in a circle, it produces a magnetic field via the right-hand rule. So if I pass my current going this way, then the magnetic field points up. So if the current flows around the loop in this direction, or from your guys' perspective, counterclockwise, then the magnetic field would be pointing out of the loop towards you guys. And if it's flowing the other way, the magnetic field would be pointing the other way. And so this is, that's basically how it works.